Properties of ideals. First property is every ideal of a ring R is a subring of R, but converse need not be true. Example, the set of all integers Z is a subring of Q, but it is not ideal of Q. That is because half belongs to Q and 3 belongs to Z. 3 is an integer. Now half into 3, that is equal to 3 by 2. 3 by 2 doesn't belong to this set Z. Hence Z is not an ideal of Q. Next property is intersection of ideals of R is an ideal of R. Example, 2Z intersection 3Z. This is the LCM of 2, 3, that is 6Z. Answer is 6Z. Again 6Z is an ideal of Z. Next property, union of two ideals of R need not be an ideal of R. See for example 2Z and 3Z. These are ideals of a ring R. Ring R is nothing but here I will take it as Z. Now 2Z union 3Z, it gives you all the elements, all the multiples of 2 as well as 3. This is not an ideal of Z. That is because see 2, 3 belongs to this 2Z union 3Z. But 2 plus 3 is 5. 5 is neither a multiple of 2 nor a multiple of 3. That doesn't belong to the union. Next, the sum of two ideals of any ring R is again an ideal of R. And the sum of ideals is denoted by I plus j equal to set of all A plus B such that first element belongs to the first ideal and second element belongs to the second ideal. Ij, this is product of ideals. It is defined as a1 b1 plus a2 b2 plus so on up to an bn. Ai belongs to I and bj belongs to j. That is the condition. This is also an ideal of R and it is called as product of two ideals. One more property is that Ij is contained in I plus j. If F is a field, then it has only two ideals. They are trivial ideals, the set containing 0 and the set itself. Z of R, center of a ring, is a subring of R, but it need not be an ideal. Say for example, center of M2 of Z. Center means all those elements which commute with every element of the ring. So A00A. M2 of Z means a set of all 2 by 2 matrices with integer entries. Now this is a subring, but it is not an ideal of M2 of Z because take one element S is equal to 1 1 1 0. This belongs to M2 of Z. Take one element from this center A equal to 2 0 0 2. Now find out RA into AR, that is SA you find out. This as per the multiplication rule, it gives you 2 2 2 0. But this element is not there in center because center has elements of the form A00A. Hence, center of a ring, this is a subring, but it is not an ideal.